Good morning, everybody, or good afternoon, good evening, whenever you're watching this video. Today we're going to be doing a little video on the product rule, and we'll explain a little bit about what the product rule is in order to find derivatives of functions. So there's our objective. Here's our first example. If you notice, it is a product of two functions, fx squared and cosine x, and what we're going to do is find the derivative. We are not able to just take the derivative of each individual function and that be done. We have to actually do some work called the product rule. What I'm going to do is the first two examples, I'm going to actually kind of let you inspect the actual solution and see if you can figure out how we're coming up with the rule for the product rule. So there's our first step of the derivative. So I want you to take notice of some things. If you notice 4x squared remains the same here. What is happening to get this negative sine x? What is happening to get this 8x? And if you notice, this cosine x remains the same. And then we simplify it to that. So take a moment and see if you can't figure out how the product rule is applied right here in order to get the derivative of 4x squared cosine x. Here's the next example, example 2. Again, it's the product of two functions, 4x cubed minus 2x and 2x squared plus 4. Some of you may think that you can find the derivative without using the product rule, and you would be right. We could FOIL these two binomials and get a polynomial function and then take the derivative just that way. But we're trying to learn how to use the product rule, so we're actually going to apply the product rule in this case. So there's the first step. Again, take a look and see what is happening. Where does this 4x come from? 12x squared minus 2, where does that come from? We see our 2x squared plus 4 remains the same as it is up here, and this 4x cubed minus 2x remains the same as that. Then we simplify by distributing the 4x, doing some FOIL over here. Now you may be thinking even that FOIL would have been easier because it would be one step. You FOIL that and then take the derivative. But again, our goal is to find the derivative using the product rule, because that will not always be the case. And then here's our final simplified answer. Some of you may have already identified what the rule is, so I'm going to show it one more time now, but just a basic thing. You see 5x to the fourth. 5x to the fourth isn't a product. You used something very similar to that as one of the functions in the product rule. And that is true, but this is a product. It's the product of 5 times x to the fourth. So let's work on this derivative. It becomes 5 times 4x cubed plus 0. If we simplify this, we get 20x to the third, just as if we would if we use just the power rule to find the derivative. But we can apply the product rule to the product of these two functions, 5 and x to the fourth. Maybe you now see where the product rule is coming from. Those you are not seeing it yet, you'll see right here. When you multiply two functions together, in this case we're calling them u and v, in order to find the derivative of them, you do the first function multiplied by the derivative of the second, plus the second function times the derivative of the first. uv prime plus vu prime. Let's apply that to this next function. You see the product of two. There's my u, there's my v. So if I'm going to take the derivative of it, and again, pause it, go back, copy it down, play it again, whatever you need to do. So there's my u, so it's u, v prime. What's the derivative of cosine x? I'm sorry, sine x, I gave it away, it's cosine x, plus v times the derivative of u prime, which in this case is going to be 6x squared. So there it is. Now we have to do a little bit of simplifying, just to pretty it up a little bit. You get 2x cubed cosine x plus 6x squared sine x. Now, in a multiple choice test, you might see answers that don't look like that. You may see an answer that looks like this, where they pull out the GCF. And again, if I just multiplied that through, you would see we would end up with the exact same answer. Alright? So I want you to take a moment, see if you can't do the next one by yourself. So you can pause it here as you look at 6x times e to the x and take the derivative. I'm going to keep going through it though. You again can pause the video, take an opportunity to do that. But here is my u, here's my v. So u, v prime. Well, we know the derivative of e to the x is e to the x plus v e to the x times the derivative of u times 6. We're going to rewrite it like this. You may have already noticed that there's a GCF, greatest common factor between these two, which is that 6, and that's what we're going to do. We're going to pull out that 6. I'm sorry, it's 6 e to the x. We're going to pull out 6 e to the x. And we're left inside is x plus 1. Alright, so here's a couple more for you to try if you want to try some on your own. We will go over the answers to these in class. Again, if you see the first one, product of two functions, you could use the FOIL method. You could try that. Or you can just go straight to the product rule. And then two others for you to try. Hope you enjoyed this video on the product rule. Johnstone out.